We're beginning Chapter 3, Systems of Linear Open Sentences. This video is for Section 3-1, Open Sentences in Two Variables. A mathematical model might require two variables. For example, 2x plus 3y equals 27 is a mathematical model for some situation. To solve an open sentence with two variables, you must determine each value of x and the corresponding y value for which the equation is true, and write those values as ordered pairs. In our example, that would mean figuring out all numbers that work for x and y so that when you substitute them in, the left side turns out to be 27. One possibility is 9, 3. It's a solution to the open sentence because when you put a 9 for x and you put a 3 in for y, 2 times 9 is 18, 3 times 3 is 9, and 18 plus 9 is 27. The solution set of an open sentence with two variables is the set of all ordered pairs that make the open sentence true. In our previous example, 9, 3 is only one possibility. There are other combinations of numbers that could be used for x and y. To determine all the members of the solution set, transform the equation to an equivalent form in which the variable y is written in terms of x. Then assign different values for x and determine the corresponding y values. Let's try that with our example equation. First step, subtract 2x. That creates 3y equals 27 minus 2x. Next step, divide by 3. That creates y equals 27 divided by 3 minus 2x divided by 3. 27 divided by 3 is 9, and 2x divided by 3 is 2/3 x if you put the numbers in front of the variable. This equation is equivalent to the original equation, but it has been solved for y in terms of the variable x. Next step, assign values for x. In the chart, I've decided to assign 0, 1, 3, 9, -3, and -6, but I could have assigned any number that I wanted to for x. Let's substitute all of these values into our expression that will tell us what the value of y is. So first, put in 0. 2/3 times 0 is 0, and 9 take away 0 is 9. When x is 0, y is 9. That is the ordered pair, 0, 9. Now let's substitute 1. 2/3 times 1 is 2/3, and 9 subtract 2/3 is 8 and 1/3. This is the ordered pair, 1, 8 and 1/3. Now let's substitute 3. 2/3 times 3 is 2, and 9 minus 2 is 7. This is the ordered pair, 3, 7. Now let's substitute 9 in for x. 2/3 of 9 is 6, 9 minus 6 is 3. So 9, 3 is a solution for x. Now -3. Negative times negative is positive, and 2/3 of 3 is 2. 9 plus 2 is 11. -3, 11 is a solution to the equation. One more. 9 minus 2/3 times -6. Negative times negative is positive. 2/3 of 6 is 4. 9 plus 4 is 13. -6, 13 is a solution to the equation. These ordered pairs are 6 of the members of the solution set of the equation, but there are a lot more. Here's another example. Give coordinates for any 3 roots of this equation. First, you'll notice that this equation does not use the variables x and y. Instead, it uses k and t, but the process is the same. Solve for one of the variables in terms of the other. First, let's do the distributive property. 2 times k is 2k, and 2 times 1 is 2. Now we can get the variable t alone by adding 6 to both sides. This makes 2k plus 8 is equal to t. If it bothers you that the variable is alone on the right side, then apply the symmetric property and exchange the sides of the equation. This equation is equivalent to the original, but it has been solved for t in terms of k. Next step is to assign any 3 values we want for k. Let's organize them in a chart. One number that's easy to multiply by 2 and then add 8 is a 0. 2 times 0 is 0, add 8 is 8. 0, 8 is one ordered pair that solves the equation. Another number that's easy to multiply by 2 and then add 8 would be to use 1 for k. 2 times 1 is 2 plus 8 is 10. 1, 10 is an ordered pair. And let's try 2. 2 times 2 is 4 plus 8 is 12. 2, 12 is an ordered pair. Here are 3 roots or solutions to the original equation. Next example. Write an open sentence in 2 variables to describe the situation and then determine 2 solutions. Jasmine's net income is less than $50. How much is her income and her expenses? We're asked to find income and expenses, so let's use 2 variables. The letter X, let's make be income. And the letter Y, let's make that one be expenses. How much money does she have coming in, and how much money is she paying out? We're told that her net income is less than 50. Net income is the disposable income you have left over after you subtract your expenses from your income. So X subtract Y is less than $50. This is our open sentence. Now we're asked to determine any 2 solutions. What are combinations of numbers that could be used for X and Y so that when you substitute them in, you get a value less than 50? One possibility is that X could be $100 and Y could be $60. 100 subtract 60 is less than 50. Another possibility is that X could be $250 and Y could be $210. 250 subtract 210 is less than 50. There are all kinds of combinations that would work. Here are 2 of them. Let's summarize the lesson. Chapter 3 is going to be about open sentences that have 2 variables in them, often X and Y, but you don't have to use those 2 letters. Solving an equation with 2 variables means to find values of those variables that make the equation true. The answers are written as ordered pairs. One good way to solve these kind of equations is to rewrite the equation so that one variable is alone. Then you can use a chart to organize your answers.